Hello and welcome to the Quantum Exchanges. I'm Siddharth Deshpande, Director of Industry Solutions at Palo Alto Networks JPAC. And today I'm joined by a very special guest, Nicole Quinn, our VP of Public Policy and Government Affairs. Nicole, welcome to the Quantum Exchanges.
Thanks, Sid. Thanks for having me.
So what are we going to do today?
So yes, look, it's been a remarkable sort of probably 6 months for me, travelling around this wonderful region, really centering our policy work on some really key events. So we had our CEO at the Indian Global AI Summit. I had my Executive Vice President at the Hiroshima A Friends Group in Japan. And I've actually just got back from an ASEAN roundtable in the Philippines talking about mainly secure AI by design. So lots of government conversations. But then the second question was, what do we have to do about quantum, Nicole? And so this is a perfect timing because from a policy point of view, from a policy consideration point of view, we're really seeing quantum start to come at the top of the forefront of policymakers around JPAC.
So we've been hearing about post-quantum and the cryptographically relevant quantum computer and Q-Day for a while now. But it feels like over the last year or so, the timelines have become a bit more urgent and there seems to be a renewed focus on doing something about the problem. What do you think that is?
Oh, look, 2030 is kind of this policy date that legislators have had across the world as kind of quantum ready. And I don't know about you, but 2025 went really quick. 2026 is going just as fast. And I think legislators are going, oh my goodness, 2030 is just around the corner. The other thing that I think has really made it at the forefront of our thinking is the rapid adoption of AI. I've been referencing this statistic from Palo Alto Networks a lot around, took us 23 years for 1 billion people to get on the internet or interact with the internet. Took us 16 years for 1 billion people to get on a mobile phone. And if you and I were talking here last year, we would have said it's going to take 7 years for 1 billion people to interact with AI. We cracked that in less than 3 years. So if technology is moving that rapidly, quantum, we think it's something in the very distant future. I think it's going to be here quicker than we thought it was.
So I think fundamentally my understanding of it is that the problem statement is that there's the potential of a cryptographically relevant quantum computer or CRQC that can potentially break classical cryptography, which means the world as we know it is potentially going to change. The jury is out on the specific timeline and there's some variances across the region.
Definitely.
But that's the problem statement that people are trying to solve for, right? And I think there's different ways that are being explored. There's the concept of QKD, quantum key distribution, which is more of a physics approach to solving the problem, which is to say, let's use the actual quantum computers to distribute encryption keys securely.
Right.
But that has dependencies in terms of infrastructure readiness, being able to have those computers in space and the national infrastructure being ready, broadband connectivity and so on. The other is post-quantum cryptography, which is PQC, which is more of a maths problem, which is to say, even if a CRQC were to come about at whatever timeline, it wouldn't be able to crack these upgraded encryption mechanisms. So which one of these are you seeing more of an interest in?
I think the second. I think from a legislator's point of view, we're not smart technical engineers like yourself. We're just people who try to create the rules for how fast we drive the car. So when I look at post-quantum from a policymaker point of view, we kind of go, gosh, there's lots of safes out there looking after our most secure data, whether it be in government, whether it be in enterprise. And what I'm doing pre-quantum is I'm picking up all those safes and I'm putting them in the back room because I think there's going to be a master key very shortly that will be able to unlock them all. So policymakers, I think, should and do often look past the technology solution and go, what is the problem we're trying to address? It's actually trying to secure that safe and those multiple safes so some bad guy can't open them all at once. And then it's for organisations like Palo Alto Networks to actually guide and help governments on what that technical solution looks like and how that can be applied in JPAC that has such a diverse digital maturity. We've got regions who are still grappling with that internet, getting on digital transformation to very highly sophisticated markets like here in Singapore. So I think this is the exciting thing about quantum for me as a policy maker, is that you actually need that private-public partnership even more to help solve the post-quantum solution.
Right. So on the JPAC perspectives, Nicole, there's obviously commonalities and there's divergences in how different leading economies of the region are dealing with this problem or dealing with this challenge. So what's been your high-level understanding of the differences and similarities across the region?
We often start with that global view. So the US has often been seen as the quantum leader with the NIST and the guidelines and the direction that they've sent. What I'm seeing more and more especially the last 18 months, is our countries adopting it for fit for purpose for this region. We're complex, we've got language, we've got diverse populations, we've got diverse distances between us, but we all have to cooperate and have a common footprint. But then I'm seeing quite unique approaches. So India is all about speed and scale. It's everything you do in India is bigger and better and faster than you would have thought possible. Here in Singapore, we often use the term lighthouse for Singapore. They are very forward-leaning in the regulatory frameworks and guide rails. If I look at Australia, we look at probably through that more critical infrastructure lens, the geopolitical, the nation-state lens, and quantum has been tied into their Critical Infrastructure Act. Japan is more of a safety lens, so ensuring that quantum ready is also embedded in AI, and that as technologies transfer, it's done in a safe and secure way. And ASEAN as a group, I think we always look at ASEAN as sort of 8 or 9 countries trying to cooperate. And I think quantum, we're still trying to get there for many of our smaller countries in the region.
And I think the countries that you have identified are the ones that usually are seen as more forward in terms of being proactive.
Yeah.
All the other countries in the region as well are doing something about it. Yep. But there is a lot of cooperation, for example, in ASEAN, at an ASEAN government level on these things. There have been events and forums that have been put together. So no doubt 2026 is going to be the year where we see a lot more guidelines and a lot more compliance regimes emerge in the region.
Yeah,
right?
I mean, we've already seen a truckload in the first quarter.
Yes.
We've seen Singapore bring out new guidelines. We've seen Japan. We've seen Australia doing their review around Horizon 2, which is the SOCI Act. I think technology is moving so quickly. Governments are trying to keep up, but that's the regulatory challenge, is how do we balance speed of technology with due diligence, smart policy making that will set up a society or a nation for success.
And I think in terms of the commonalities, one of the things that I'm seeing common across all of these from a technical perspective is organizations are being asked to get visibility of their crypto assets. Build that visibility first, because you need to understand what's happening, what kind of cryptographic debt you have. CISOs and CIOs are being asked to put in place a quantum readiness roadmap in different ways. So the time to act is now.
Yes.
Whether the timeline prescribed by the country regulator is 2030 or 2035, everyone's putting in place those foundational elements today, which is why at Palo Alto Networks, we've introduced the Quantum Safe solution earlier this year, and we had this big event called the Quantum Safe Summit as well to kind of put some structure around these things so that despite the variances, we have some common design principles that we can use to get our customers ready for it.
And I'm pinching your good work, Sid, when I talk to governments to give them that there is a solution. Because often it's like, we know the problem, Nicole. We know that as a government or as a society, we have to address it. But how? Yeah. And it's fantastic that I think Palo Alto Networks is such a world leader in helping governments and our customers, which are often the same, prepare for quantum.
Yeah, and the other similarity that I find is there is a lot of focus on critical infrastructure, government, and the financial sector. These three tend to be the first constituencies that need to act sooner, but it's generally applicable broadly across the industry. But in terms of the differences, we'll talk about the specifics, of course, but there seem to be some countries that are doing QKD, quantum key distribution, and post-quantum cryptography, both in a hybrid approach, and there's some countries that have said QKD is not ready yet. It's still emerging, so focus on PQC. So that's interesting to see that that kind of dynamic, and that really depends a lot on the local nuances
the maturity in cyber,
infrastructure, the types of industries as well, the geographic spread. For example, here in Singapore, internet connectivity, broadband, all of that is really good, because of which there has been a lot of focus in the financial sector on the QKD perspective. There's a national QKD program and so on. So it's interesting to see the different perspectives.
And I think you can almost apply what sectors are already regulated. Like in Singapore, in Australia, the banking sector is heavily regulated traditionally because you've got people's money. If the financial sector fails, that has dire economic and national security consequences. So governments have regulated them in a traditional way of ensuring compliance and reporting standards. And I think what we see then is governments naturally can apply that regulatory framework or approach into the cyber industry or the cyber security framework, and therefore then quantum. I think it's the countries that don't have that natural regulatory environment in those critical infrastructure areas. We're struggling with regulating them anyway. How do we then prepare them for this thing that we think is coming, but we don't quite know? And that's where I think we as Palo Alto Networks really understand our JPAC customer. We understand that customer does not look the same. With the utmost respect to our US friends, they are dealing with one large, very powerful market, whereas we've got different languages, different cultures, different digital readiness, and therefore regulators are all operating at a different level. And I think the frameworks that we are producing and the direction and the strategic technical advice is actually enabling us to really have a great private-public partnership for regulators.
Absolutely. And in terms of those common principles which apply all across, right, our quantum safe solution that basically comprises of 4 key design principles, which I like to think of as first principles. So the first one is having continuous visibility through asset ingestion, not just the stuff that we as Palo Alto Networks offer, but also other systems and third-party infrastructure and software and EDR systems, vulnerability systems, CMDBs, all of that. So it all has to go into one place that gives you that visibility of what is actually quantum ready, what is quantum safe, and what needs to happen to get those assets into a quantum safe state.
That's really interesting because our research tells us that the average enterprise is dealing with 83 different solutions by 23 different vendors. So that's really complex when I look at an AI problem, let alone if I'm then trying to measure or see a quantum issue.
Absolutely. So we need to put in place the foundational architecture that we call platformization, which is to simplify the environment so that you can amplify the security coverage. And that's really what it's all about, because we can't go into the quantum era carrying forward the problems that we've inherited over the years in terms of complexity and technical debt. So that visibility is really important. And the next part of it is really about prioritization, right? Obviously, some systems handle more sensitive data. Some systems are more business critical, are more in the regulatory scope. So whatever solution you're putting in place needs to make sure that your risk remediation plans are aligned to the criticality of the systems. And then comes being able to remediate, being able to implement mechanisms and have a real-time visibility of, hey, what are the systems that are quantum ready, which have the software and hardware capabilities to upgrade to the newer quantum safe algorithms, and what needs to happen to get them to that quantum safe state. And if there are systems that are legacy that perhaps do not support the upgraded ciphers, upgraded encryption mechanisms, and we also offer a cipher translation proxy that allows you to put in that advanced encryption before the traffic leaves your network, so that if an attacker were to capture the data, they can't really decrypt it, even if the CRQC, cryptographically relevant quantum computer, becomes available. So that's number 3. And then the 4th thing really is about maintaining a continuous compliance and being able to have that continuous visibility of the cryptographic bill of materials, so that it's not a static point in time exercise, right? You can't, in the age of AI,
can't set and forget.
It's not an audit exercise, it's not a patching exercise. It's really about building the foundation to make sure that we have that continuous visibility and reporting against various compliance regimes. So if, in my conversations with customers, if these 4 things are broadly put in place as part of the quantum readiness strategy, then it allows them to then be flexible and address different regulatory regimes across the region? Because a lot of our customers are global organizations, also JPAC-wide, so they have to comply with these mandates across countries.
And we always, as policymakers, talk about harmonisation, interoperability. As a global company, you don't want to have 132 different sets of regulations and compliance issues, because that creates a burden, a cost, a complexity that is impossible to address. But you also, I think what we do really well in our organisation at Palo Alto Networks is adapt it to some of those sovereign or unique regulatory requirements. So you've got that universal common starting point, like a NIST framework, for example, with quantum, and then we're enabling our customers to customise to the uniqueness of the regulatory environment in particular countries.
Sounds like an actionable plan for sure.
Sure does.
Yes.